Welcome to today's webinar, Multiplex Bead Array Analysis in FCS Express 6. For those of you who have just logged on, if you can just take note of the questions and answer box, which I've shown here circled in yellow in the bottom right-hand corner of my screen, where it says enter a question for staff. You can enter in a question as we go along, and either I will get back to you verbally or our staff member, Raphael, who's on the line, will get back to you in the chat message. And if the question's in more detail, we'll certainly follow up with you offline after the webinar as we have everybody's email address. Okay, well, thanks so much for coming. So I know a lot of you are analyzing multiplex bead arrays or even single bead arrays, and those come in many different varieties. A lot of companies out there offer multiple kits with different configurations of beads depending on, what you're trying to do with immunology or analyzing multiple growth factors or whatever the case may be. There's lots of kits out there, and there's also mix and match type single bead kits or single beads that you can buy singly and then combine them into your own sort of custom analysis. And whatever the case may be, it all just makes FCS files, and so you can certainly analyze them in FCS Express with the procedures that I'm going to outline for you today. And the advantage of doing it all in FCS Express rather than doing it in another flow software is that everything is going to be self-contained in FCS Express. So there's no need to analyze your FCS files in a flow program and then export that to Excel. And then many times you have to spend additional hours taking that data from Excel and putting it into other statistical analysis programs like Prism or StatView or what have you. And if you count up the hours that you spend doing that, especially if this is something you're going to be doing even on a semi-regular basis, it really does take a lot of time. So we try to provide as many tools as we can for you under the same umbrella of FCS Express. And I hope I can sell you on the idea of doing it all in the software that you presumably already own or are trying out. All right. So, like I said, feel free to interrupt me throughout the course of the webinar. I'm happy to address your questions if they're relevant to what we're talking about. And if they're not, we'll certainly follow up with you offline. Okay, so let's talk a little bit about a brief outline that we'll be following. So, like I mentioned, FCS Express can efficiently analyze your multiplex bead array data and present the results in easy-to-interpret bar plots. In this webinar, we will be showing you how to create standard curves based on your serially diluted standards. Okay, and that makes use of a couple of different tools, in addition to obviously creating plots and gates and statistics, which we're assuming that you have a basic familiarity with. It's going to make use of spreadsheets, which is like an embedded Excel-style spreadsheet with all the tools and formulas and tricks that you're familiar with from Excel, except it lives right here in FCS Express, so there's no need to go to Excel. And then from those spreadsheets, we'll be creating a scatter with regression plot, which is shown right here. This is just a snapshot of one, but we're going to be creating some real ones where you have your raw data values from your serially diluted standards, and then we're fitting a 4-parameter logistic best fit curve to it. We also have 5-parameter logistics, so that's up to you as a scientist about what you want to use. Usually they give quite similar results. It's just a difference in the 4-parameter logistic assumes symmetry, and the 5-parameter logistic makes an allowance for a lack of symmetry around the inflection point there. All right. So next, we're going to be talking about how to interpolate the concentration of your unknown samples. So typically these experiments, after you create a standard curve, you have a number of unknowns, and those are the samples or the FCS files that you actually want to calculate the concentration of various solutes, whether they're cytokines, growth factors, whatever the case may be. We're just going to be using the example of generic cytokines today for illustration. But it really doesn't matter, of course, okay? It's all math. Lastly, we will be summarizing the results in a bar plot. So it's nice to look at the actual values of your interpolated concentrations in a spreadsheet And a lot of times that's what you need, but sometimes for posters or publications or presentations or even simple lab meetings, you really want to summarize that in a visual form that makes sense at a glance. And so we have the ability to make bar plots. They can be as fancy as you need them to be. So in this example here on the left, we have a bar plot that's graphing the mean and the standard deviation of replicates, triplicates to be exact. So the means are the bar values and the standard dev has been graphed as error bars there on the bar plot. And then here's another example on the right where we have overlays where we are graphing multiple cytokine results on the same bar plot. And in each cytokine, or in whatever the case may be, if you're analyzing, something other than cytokine, but each solute here is a different color on the graph, and it's essentially a bunch of overlays on the same bar plot. Okay, so there's really a lot of flexibility about how you want to present your results, and it depends on the logic of your experiment and what you're trying to prove. There's even things you can do like in having p-values and testing for significance. We're not going to get into that today just because we don't have time, but we do have another webinar which goes further into depth on that matter, and I'll point that out at the end of the webinar where that archived webinar is, because I think it might be relevant for some of you, especially if you're analyzing replicates. Okay, so those bar plots, again, they're going to make use of spreadsheets and, of course, bar plots. And we're also going to show you how to reuse the layout as a template. So that's something that we do a lot in our webinars, but I think it's really, really important in this webinar because there's so much work involved in creating these analysis with the workflow that you probably have going now. And it still is a little bit of work in FCS Express, but you'll see we can fit it all in just a few minutes. And once you've created it once in FCS Express, there's really no need to recreate the wheel over and over again. You can use the same template over and over again for similar experiments, and that's going to reduce the amount of time you need for analyzing subsequent experiments to literally seconds. No exaggeration there. And there's even flexibility. You don't need to be acquiring the same number of samples every single time. Even the number of standards can change, and that just requires a small adjustment to your template. And that's an adjustment you can make on the fly as needed. Okay, so let's go ahead and proceed. I'm assuming we don't have any questions right now because we just went through the outline rather. But what I'm going to do is kind of unusual. I'm actually going to lead with the reuse of a template that's already built, because I want to show you that it really is very fast to reuse that layout over and over again. So I think that'll make you more motivated to make the template, seeing that it's literally going to be 10 seconds just to reuse it for when you repeat the experiment. Okay, so I will walk you through how the templates work right after I just show you the quick loading of an empty template. So right now, this is an empty template. It's actually been saved as a panel. Just to show you the setup of this panel, it's set up as several different tubes. At the top end of the data list, we're loading in our standards going from high to low and negative. You don't need a negative standard if you don't have it, but in this case we do. And then it's followed by all the samples in the data list. We actually have an excess number of tubes, and that just builds in the flexibility to just load in however many tubes you need to analyze. And keep in mind, I'm going to show you how to convert your layout to a panel, which is what allows you to use it as a template once we actually build an abbreviated layout from scratch, okay? But for now, I'm just going to load in all the samples and show you that all of these pages, so this is the page that's going to have our gating, this is the page that's going to have our regression plots with our best fit curves, this is the page that has the spreadsheets with our interpolated concentrations of unknowns, and this is the page that has a few different bar plots showing the summary of the concentrations of our unknowns. Okay, so I'm just showing you all these pages to prove that I've got nothing up my sleeve. These are really not populated. So I'm going to load in my samples, and you'll see that everything is going to come in just fine and dandy. So we have all of these and our negatives. So these are all my standards up here. up here at the top. We've also got a negative down at the bottom, and then down here and a little bit further down are our samples. All right. Okay, so I'm just going to go ahead and open all those files. The only thing we need to do is the samples come in alphanumeric order, and so the negative or the zero concentration standard is here at the bottom. So I'm just going to move that up just by dragging and dropping so it matches the standard, the negative tube in the panel. Okay, so now everything is good. We have our standards here at the top, which I'm highlighting in the data list, and our samples down here at the bottom. And everything is all set up. So this is a layout that I'm going to show you how to build in a moment, but just to take you through a quick tour, we have the beads gate here on forward scatter and side scatter, and then we have a number of marker gates here based on the identity parameter, which is FL3 height, and the quantitation parameter in this experiment is FL2 height. Okay, so this is the negative sample. If I show you these other samples down here, these other standards down here, we're going from a 1 to 2 dilution to 1 to 4 to 1 to 8 and so on, serially diluted twofold down to 1 to 256, which is this one here, and then the negative. So you can probably see, maybe if I zoom in a little bit more, that we have some variation on the FL2 height parameter because of the dilution, right? So these are all essentially negative, between 10 to the 0 and 10 to the 1 of FL2 height, because that's the negative standard. And then if I take a look at, for instance, this 1 to 4 standard, you see that we do have some values here, positive values here, registering on the FL2 height x-axis. Okay, so if we go to this other page here, we have the standards, the standard curves that have been populated based on the spreadsheet, like I mentioned to you. This is a very spreadsheet-intensive webinar. And then on the third page, we have a couple of different spreadsheets, one for the 24-hour sample, and then at the bottom for the 48-hour samples. You could keep them, if you wanted to, all in the same spreadsheet. Actually, that's how we'll build it today. But when you keep them in separate spreadsheets, that's what allows you to sort of have overlays. If you wanted to overlay the 24-hour and the 48-hour bar plot on top of each other, so you can do an analysis at a glance of how things change after 48 hours of treatment versus 24 hours. So cytokine 1 seems to be decreasing. I can change these axes to any other cytokine I want to look at. So cytokine 3 was below the limit of detection. I don't have anything there. There's cytokine 6, cytokine 7. Okay, so we could have actually built this to have separate bar plots, duplicated for each cytokine, but in this case we've just built it so we can just change the axis here on the fly. And then here we have the results presented as overlays of different cytokines for all the samples on the same bar plot. Okay, and it's all color-coded to match the gates that we used here in our gate view. Okay, so I know I went through that pretty quick, but I just wanted to show you, if you're keeping track, that was probably less than 15-20 seconds of loading the samples into the data list, and everything is already set and ready to go. So that's our goal. We want to take you to that point where you're able to make a template like this, and it probably won't take you more than, well, it depends on, the complexity, but we're going to fit it all in today in a portion of today's webinar, and then you'll be able to reuse it over and over again. Okay? So let's close that up, and let's go ahead and start building a layout. Okay, so I'm going to make a new layout. And we'll open our data list, and let's load in our files. So let's load in our standards from here. These are our serially diluted standards. And I'm going to load in my samples as well. Okay, we'll take all of these 24-hour and 48 samples. So we have different samples, A through H, and they were each treated for 24 or 48 hours. So we'll just analyze all of them today. Okay, so again, I'm not going through the basics in excruciating detail of how to just insert plots. I'm just going to go ahead and do it. So this is, we'll look at a density plot to start off with, forward scatter versus side scatter. I'm going to put these on log. Usually we're defaulting to linear for scatter parameters, but in this case, just the way these samples were acquired, we're going to want to look at log versus log. All right, now we'll create a gate on our beads. And maybe let me zoom in a little so it's a little bit easier for you to see. All right, so let's drag and drop this beads gate out to look at a new plot. So the template I showed you before used histograms with markers linked to gates. You can do that, just to refresh your memory. It looked something like this. Okay, where when you move these marker gates around, the gates that are linked to them are updating. So if you keep an eye, for instance, on this pink cytokine 7 gate, you can see that this gate here, which is on all of the serially diluted standards, is moving when I move the marker. So you can create the gates that way if you want to, but a faster way might be to just go ahead and create marker gates on a 2D plot. So that's what we're going to do. So let's change this to FL3, and this is our FL2H. All right, and we'll create a couple of different gates here. We're not going to create gates around each of these different cytokines. Let's just do maybe 3 of them for expediency. So we'll create a marker gate on a 2D plot. And I'll call this cytokine 1. Okay, you can actually just maximize the plot for ease of creating the gates here. Giving them the correct borders. We'll create another gate. Cytokine 2. And we'll create another one around cytokine 4 here. Okay, so we could have gone through and done all of them, but I think you get the idea. Now, this is the 1:2 dilution of the standard. I can go to the data list and click on the plot and just kind of cycle through by going next on selected and look at, you can watch the populations moving backwards on the FL2 height parameter x-axis because we're going down in dilution, right? So if I keep going all the way to the negative, everything's going to essentially be negative or very low for FL2 height. Okay, so that's actually really all we need to do for the standards in terms of inserting plots. You can, if you want to, insert multiple plots for all of the standards, like for QC purposes, you could do that if you wanted to. It's really not necessary just because the gates are by default global in FCS Express. So once you've created them on one plot, they essentially belong to all plots. So you don't really need to. But if you want to, for your own information, an easy way is to just drag out the plots over and over again, or maybe do a Control-D to duplicate and then change the file on that plot. And then, we have all these align tools under the Home tab where you can align the tops. Okay, I'm just going to skip it for today, but one other shortcut in case this is something you want to do on your own is you can just select that plot and hit multiple duplicated next here on the Home tab. And then you can say you just want to create, however many more standards you have. And then this will duplicate them out for you and it'll go down the line from your 1 to 2 standard down to your negative, or whatever your lowest is, okay? But like I said, we don't really need it, so we're going to skip it today in the interests of keeping our layout simple and easy to make for the webinar. Okay, so let's go ahead and make our spreadsheet. So remember, we want to make a spreadsheet on which the scatter with regression plot is going to be based. And that's the plot where we're going to have our 4-parameter or our 5-parameter logistic curve that serves as the basis for interpolation. All right, so let's put in a new spreadsheet. I always like to give my spreadsheet a name. It just helps keep track, especially if you're making a layout with multiple spreadsheets. So I'll just call this my standard curves. All right, so let's, this works just like you're used to with Excel. So you can start typing in free text. So I'm going to put in my dilution factor here. And here's our actual concentration of the standards in picograms per mil. And here we'll type in the MFI of FL2 height of cytokine 1. And we can do a row fill here. And then you have the results, the titles of the columns here for cytokine 2 and 3. Let's change this to 5 just because I know cytokine 3 is below the limit of detection for a lot of my samples. Okay, and you have all the formatting options here as well. So if you wanted to make these columns more narrow, and then you can come up here to your layout tab and format the cells to be wrap text. So this should look familiar to those of you who are already used to working with Excel. Okay. There we go. So that's starting to look nice and neat. And now we can start filling in these rows. So the dilution factor at the top dilution we did was 1 to 2, and then we did a 2-fold dilution down to 256. So I could just start typing it in manually, but I can also use the handy Excel tricks that you're already used to, which is just the divided by 2, and then you can do, whoops, I'm sorry, I meant to do a times 2 because it's the factor. So times 2. And then we can do our row fill. Okay, and then these ones. Our last one is a negative. And then our top dilution was a concentration of 2,500. So that's something that you need to know, you know, from your own kit or your own lab notebook, of course. It's going to be a hard-coded value. I'm entering it in freehand, but if you had that value as keywords from your samples, you could simply drag that sample. Well, you could actually just drag all the samples into here and select keyword token. And then you can scroll down to, you know, wherever it was. So you might have a keyword called concentration, or maybe it's your sample ID or something like that, and you could select that here. Okay, I actually don't have that for these samples, so I'm just going to enter them in freehand. But again, I could use that handy trick of dividing by 2, since these are 2-fold serial dilutions, and just quickly fill in the results there. And then this one is 0, of course, because it's negative. Okay, so now let's put in our MFIs, and these are, of course, going to be the Y values for our scatter with regression curve. Just to refresh your memory, I know we've talked about a lot of things already. What we're trying to build right now is this curve here for all of the cytokines. We're going to just do cytokine 1, 2, and 5 today, or 1, 2, and 4. I can't remember which one we chose. Okay, so we're going to actually have 3 different regression curves off which to interpolate our unknown values at the end. All right, so here we can drag the results directly from the data list. So I'll just select all of these files from the data list. Those correspond to my standards. Put in our statistic token, and the quantitation parameter again is FL2 height. The gate we want this time is cytokine 1. See, we're filling column C, which corresponds to cytokine 1. And we're going to put in the median. Okay, that's up to you what you want to analyze, median. Traditionally, I think most people choose median, but you can choose other measures of central tendency if you feel it's more appropriate. Okay, and let's go do these same things for the other cytokines we chose to do today. So again, we want to do FL2 height as the quantitation parameter. See? We're going to choose cytokine 2 and the median. And lastly, let's come over here and do our cytokine 5. Oh, okay, cytokine 4 is the one we decided to do. So I will just correct this. And let's save this just in case. Okay, any questions so far? So now we have some X values. It's going to be the concentration in column B, and then we have the Y values in column C, D, and E. And we're going to make 3 separate scatter with regression plots, one for each cytokine. Alrighty, so we're going to come up here to the Insert tab and select Scatter with Regression. And it's going to default to columns A and B for the X and Y of the standard with the scatter with regression. We would like to have the actual column titles appear here in the axes. So we'll just format this spreadsheet to do that. So if you come down here to spreadsheet data and just check this box here, use values in first row as labels. Okay, and so now you see we have those showing up on the axes, and we can choose the one we want. So we want concentration on the x-axis, and let's just do the cytokine 1 scatter with regression curve for now. We need to make a couple of formatting changes to this, not least of which is, of course, changing the regression type. It's just defaulting to straight y equals mx plus b linear. So let's go and change all of these things. Those of you who are familiar with FCS Express, just right-click Format, probably is a familiar tip to you, and all of the formatting changes you want to make to any kind of plot are there. So the first thing we will do actually is come to our axes and change my x-axis to log. Okay, so now you can see from looking at the raw data points that you're starting to get a little bit of that S-shaped curve that you're expecting. We will come here to regression fit and change this to 4-parameter logistic. Okay, you could do 5 if you wanted to, whatever you want to do. Do a preview, and you see that fits really nicely. We have an R squared of very close to 1. We will insert a scatter with regression text box to the right, so you'll have these summary statistics of the IMIN and the IMAX, which those of you who are already analyzing this data, you know that represents the limit of detection, the high and low limits of detection for this type of data. Okay, so a few other changes we'll make. We'll change the title to something a little more descriptive. So why don't we call this cytokine 1 standard curve. Okay, you can get rid of the background, whatever you want to do. And let's see, is there anything else we want to do? Let's change the overlay color. So we made our first cytokine red. So actually it did default to red here for the color of the regression. But we can make the regression line a little bit thicker so it's a little bit easier to see. And so you'll want to change this line options to connecting lines. That represents the color of the best fit curves. Oops. think I did something different there. Hang on. Oh, yeah. Okay, sorry. Let's come back in real quick and alrighty, and for parameter, I apologize. I chose the wrong overlay. So we want to format the overlay. The first overlay is actually the black raw data points, and that's fine. We can leave that alone. But you want to click here on 2D unbinned overlays if you want to have the color of the gates match the color of the best fit curve. So it does match in this case because the cytokine 1 gate is red. But what I will do is just change the connecting line to be a little bit thicker, so it just looks a little bit nicer. All right. Okay, so let's put in our statistics text box here with the regression parameter statistics. You can get that from the right-click menu. Okay, now here comes the nice high throughput aspect of this. So if you were doing this in Excel and Prism, you would have to go through this whole rigmarole and kind of make the plot from scratch, again, from the other rows of data. But in FCS Express, you can just grab these files, do a Control or Command D to duplicate, and duplicate it one more time. Okay, and now I'm just going to change the axis just by clicking the Y-axis to cytokine 2 here. And this one is cytokine 4, okay? And you see, of course, the statistics have updated on the right in the statistics text boxes, and I will change these overlay colors to match the gates, which is purely optional, but I think it's a nice touch, and it makes your layout a little bit easier to read. So this one is blue because it's cytokine 2. There we go. And then here as well, we'll change this cytokine 4 plot to green. Okay, and we want to, of course, change this title to, this is the cytokine 4, and we will change this title to the cytokine 2. Whoops. Okay, so that's good. Any questions so far? You know, just to let you know, if you did want to do a 5-parameter logistic, it's as easy as coming here to right-click format and going to regression fit and just choosing 5-parameter logistics. So you can watch the statistics are going to change a little bit. Whoops, not sure what happened there. Usually that works fine. I'll just have to check what the issue was there, but okay, we'll come back to it later on. But I assure you it will work if you want to do it that way. So let's go ahead and go to the next step, which is doing the interpolation of our unknowns. So let's name this page just so we can keep everything straight. So this is the standard curves. And now we will put in a new page and call it the unknowns interpolation. Oops. Okay, so we'll put in a new spreadsheet now, and I'll call this the unknowns interpolation. And we will make the column headings. So the first one is going to be the file names from all our unknowns. And then we're going to have the MFI of FL2H of cytokine 1. I'm going to wrap this text again just to keep things nice and compact. All right, there we go. And we're doing cytokine 4. And then we're going to have additional columns for the interpolated concentrations. right, so let's grab our file names. So we will select all of these here and just drag them in one fell swoop over and put in the file name. You just have to select an arbitrary parameter here or you'll get an error message. There we go. And now we will put in the MFI values for all of these. So again, it's just a drag from the data lists, very short and sweet. The parameter FL2H, that's our quantitation parameter, cytokine 1, median. This is very similar to the procedure, or identical actually to what we did with the standards. This is going to be the same thing, FL2H, except we're choosing cytokine 2 and the median. And lastly, we'll do this one, cytokine 4. Okay, so here comes the fun part. You'll see how easy it is to get the interpolated values, and this is really where the efficiency, I think, should shine of FCS Express, because you don't need to create the curves. We've already done that. It was very easy to just duplicate them one off of the other, and now we're just going to do an interpolation with the formula fill for the entire list of samples. So you'll type in equals, just like you would when you're typing a formula into Excel. Come up to your Formulas tab on the spreadsheet, and here under Statistical, we'll scroll down until we get to the R's. So this is what we want, regression plot y to x, because we know the y value, that's the MFI, and the x value is the interpolated concentration. So we'll type that in. And now we do have a guide to the syntax online, which I will point out to you later. Well, I can actually show you right now. So this is the help online. You can also get to it if you click on the startup screen on help and manual. It'll take you to the same page. But just to show you what the syntax is going to look like. Okay, here we go. So this is the syntax right here. So we're going to want the plot number of the actual plot with the curve, and then the overlay number is always 2. Don't worry about y. You're always going to enter in 2 there. And then the y value is actually the MFI values that we just put into the spreadsheet. Okay, so let's put those in. So where do we get the plot numbers? You can get that by mousing over the plot. So do you see the hover text here? This says 6. This one here is 8. And the cytokine 4 one is 10. You can also, if you're having trouble getting the hover text to appear, you can just right-click Format, and it will say right here in the title bar of the formatting window the plot number. Okay, so cytokine 1 plot is 6, this is 8, and then this is 10. So we'll come up over here, and I'm going to type in the plot number inside of the parentheses, 6. The next number is always 2, and then the next number is cell B2, which is the y value. It's the MFI of FL2H, okay? And we can do a row fill here, and you see this has, it's updated the relative reference, so it's taking now C2, and this one is taking now D2. That's correct. We just need to change the plot number here. So this plot number 6 refers to the cytokine 1 regression plot, and we want it to refer to the cytokine 2 regression plot, so we'll change it to 8. That's what I got from the hover text on the previous page. And then this one here we will change to 10. Okay, let's just double check. Yep, great. And now, so those are the actual concentrations of sample A, 24 hours. So we could just grab all of these and do our our row fill, just like you would in Excel. And you see in a jiffy, you have got all of the concentrations from all of your samples there. Okay, some of you might be wondering, why do I have a value error in some of these? And that's just because if you notice, these are all in the 48-hour samples. It just so happens that the 48-hour samples were either below or above the limit of detection based on the Imin and the Imax of the curves for cytokine 2 and cytokine 4. Okay, so let's go ahead and do the next step, which is inserting some bar plots to summarize these results. And I think you'll like this. It's so easy, and it's really nice visualization, even if you're just needing this for your Monday morning lab meeting. So we will, again, format this spreadsheet to take the column titles as the axis titles for the upcoming bar plot. So we'll check this box here to use the values in the first row as labels. And now I will put in a bar plot. So when you're putting in a bar plot, you just want to click on the spreadsheet first, and that way the bar plot will automatically come from that spreadsheet, okay? Otherwise, it might have come from the other spreadsheet that you were building before. So just click on it, come onto the bar plot, come up to the bar plot button here on the Insert tab, and then just draw your bar plot. And this is good. We want to change the y-axis, of course, to the concentration of cytokine 1. And let's just change a few different formatting options here. The first thing that I want to change is the title, and I'll call this cytokine 1, or let's say cytokine concentrations after treatment. We'll come over to the axis, and you see like not all of the file names are showing up here on the x-axis because they just can't fit when they're going horizontally. So I'm going to change the labels to go to a 90-degree, whoops. Okay, now you can see all of them. And just because I like things to match, I'm going to change my overlays to be red because that was the color of cytokine 1. All right, and I'm going to change the axis name because we're going to add some overlays. Well, we'll do that in a minute. Let's just accept that change for now, just to remind you of the gate colors here. Okay, so we're just going to match cytokine 1, 2, and 4. So you see, this is basically your results. And if I do a 2-page view, this is going to update as I move the gates around. So watch as I move the beads gate, you can see the bars and all the numbers in the spreadsheets changing. And even if I were to, change the gates here, for instance, if I make cytokine 1, if I adjust the gate position, that is changing as well. And even the standard curves are changing too. So, keep an eye on that standard curve 1 at the very top here, this plot right here. It's, of course, changing as I move the cytokine 1 gate. You can probably see the Imin and the Imax changing. Or if I move the parent beads gate around like this. Okay, all of those numbers are changing as well. So everything is live updating, which is a really great advantage of doing everything under the same umbrella in FCS Express rather than several different softwares, or if you have to nudge the gate or change the type of fit you're doing, and you'd have to go back and pick up from where you left off and redo all that work, right? So that is cool. You can, at a glance, look at the results from cytokines 2 and 4, of course. And let's show how we can actually make an overlay. So I want to overlay the results of cytokine 2 onto this. So the first thing I'm going to do is just change the title of the y-axis to be more generic. So rather than cytokine 1, I'm just going to call it, we'll change it to the specified text below. And we'll enter in a more generic y-axis title here since we're going to be looking at several different cytokines. So type this in. Okay. You can change the size of the title as well. All right, so how do we make an overlay? It's actually quite similar to making an overlay with a regular histogram or plot where you can just drag plots onto each other. So the same thing, except in this case, the overlay is using the spreadsheet as a source. So we'll just grab the spreadsheet by its border and drag it onto the bar plot. And you see when you're doing it right, your cursor will become a little plus. And then you get this prompt asking if you want to replace or add the files to the plot as a new overlay. So we'll do the latter and click OK. All right, and now we will come in here and just format the second overlay to get the values from the correct column. So in this case, we actually want to have the second overlay get the results, or sorry, get the values from column F, which is concentration cytokine 2. And I will even make it match my gate view. The cytokine 2 was blue. Okay, so there you go. And we can put in a legend. All right, it's going to default to the name of the spreadsheet, but you can just come back here into overlays and type in the appropriate label up here as well. There we go. All right, so you know, if I wanted to, of course, I could go and add the same thing for cytokine 4, but I think you get the idea, right? So let's save this. And I'm going to show you, before I show you a couple other flavors of the layout that you can make, you know, with error bars and such. I want to show you a really important step, which is, of course, how to save this layout as a template and use it over and over again. So the first thing you'll want to do is save the layout as a panel. And the panel is what allows all the plots to know, sorry, all the files in the data list to go to the designated plots and such, and to populate the spreadsheet in the appropriate columns and rows. So we'll come over here to, you can actually get it from the data list up here, panels, or down here where it says no panel is active. And just add a name to the panel. So I'll call this our multiplex. And I just give it an excess number of tubes. You can even type in 100 tubes. And I would give the name, you see how my tubes 1 through 9 are my standards. It's not mandatory that you give the name, but it's suggested just because that way it'll help you keep your standards in the correct order. You know, in my case, I built it going from high to low. It doesn't matter how you build it, but you want to follow the same convention each time. So this is my standards low or negative. And then beginning with tube 10, we have our samples. See, I only have 27 tubes total, but I've made space for 100. That way there's a lot of flexibility in my layout, and I could, you know, easily just load more files into it. Okay, so I'll say okay. All right, so I'm going to save this. It's now saved as a panel. And now what I'm going to do is save it as an unlinked panel. Okay, and that's what's going to make it come up with empty plots like I showed you at the beginning of the webinar. Okay, so I'm going to call it webinar multiplex unlinked panel. Now I'm going to close and reopen it. Okay, so like I mentioned, you know, everything is coming up empty. That's expected. And now we just need to load in our files. And just to prove to you that it doesn't need to be the same number of samples, let's say that this time I only, you know, acquired all the 24-hour samples and maybe just three 48-hour samples instead of, you know, instead of all the 48. It doesn't need to match up. You can use a fewer number of tubes than you used before. But let's not forget to take my negative standard down there at the bottom. Okay? So in that case, you know, you'll get a message stating that you don't have enough tubes. That doesn't matter. You can ignore it. As long as you've got fewer than the number of tubes you originally defined, everything works nice and neat. You see this is live updating, of course. Right? Very cool. I come to my unknowns page, and you're just going to get some errors in your empty rows because I don't have as many 48-hour samples as I did before, and they're also showing up as blank space in my bar plot. No worries, just go ahead and delete these. And you see, I want to delete the negative, whoops. Forgot to reorder the negative tube up here. So let's just bring that up here into my low standard All right, there we go. So now when we delete all of these, okay, so you see now everything looks nice on your bar plot. I still have a few empty samples, empty looking tubes, just because those are below the limit of, those particular samples are below the limit of detection, okay? But it does get rid of the empty rows for you. All right, so any questions about that? I just want to, I was a little concerned. I'm not sure if it has something to do with this particular data set, but if I insert a new scatter with regression plot, I'm sure I can get the 5-parameter logistic curve to show up for you. So I'll change that to concentration, and go ahead and come back and make a couple of these changes, like changing the x-axis to log. Okay, there we go. So we have a nice 5-parameter logistic curve right there. So rest assured, whether you want to use the 4 or the 5-parameter logistic, the latter making allowances for asymmetry, you can do that in FCS Express. It's probably just something with this particular data set that just didn't quite like it. Okay, so feel free to do that. And you know, in these last couple of minutes of the webinar, I just want to quickly show you, you know, a couple other examples, or maybe just one other example if that's all we have time for. Yes, this is the one I wanted to show you. So here we have a different kind of bar plot where we're plotting replicates with error bars, i.e. the means as the bar values and the standard deviations as the error bars. So if you're acquiring your samples in duplicate or triplicate, you can certainly do that in FCS Express. I'm not going to have time to build this bar plot in the spreadsheet with you from scratch, but just to show you how you can do it, you'll want to basically put in all of your sample IDs or your sample names here in column A, and then you want to have a different column for every replicate. So we have columns B, C, and D, replicates 1, 2, and 3 for cytokine 1, and then cytokine 1 mean. And these are formulas that you can get here from the formula bar. See, we have average, and then this is the standard dev, which you can also get from the formula statistical button. And then you're going to have basically those same 5 columns for every single cytokine that you want to do, okay? And it's actually really easy to sort of do a, excuse me, to do successive fills for like additional cytokines. It's, you can just kind of grab these and do a Control-C or Command-C on a Mac and do Control or Command-V to paste. And then you'll just need to come in here and change the gate. So like if you right-click Format Token and go to Statistic, you can just change this to be cytokine 5, okay? Oops, you want to right-click Format Token. All right, and these means, these array formula here, they have updated their relative links. You might find, I guess, this one seems to be a little bit of a transpositional error, but that's okay. Just delete out this reference here and select the appropriate cells. All right, and then you can do a column, I'm sorry, a row fill here, like this. There's a couple different ways. Whoops, a couple different ways you can fill these, like that. And now you'll want this to refer to sample C, right? So sample C, replicate 1, 2, 3, and here you could come in here and change the tokens data source here. Assuming your samples are named similarly, you can just call this sample B, replicate 1, and now we'll come over here. because everything else is going to be the same, right? Cytokine 5, that's all static. We're just changing which file it's referring to. Okay. You can also use this change file on tokens. That'll get you to the same place. And yet another way, I don't want to overwhelm you, but I just want to show you it's very flexible. So you can be creative, have fun with it. You can also put it in by a drag. So I can just, the next row I need to fill here is sample C. So I can grab these sample C replicates and drag them to a different cell and put in cytokine 5, parameter 28, FL2H median. But when you drag them, they come in as a column, and you want to put them in a row, but that's okay. You can just move them like this. So that might be another way that you'd like to do it, okay? And then you can easily just grab these means and standard devs, and just do your row fill like that, okay? And now I will simply grab, I want to make my overlay with the cytokine 5, so I'm going to just grab, again, the spreadsheet, drag it into the bar plot, say add it as a new overlay, and now we'll come in here and we need to format the bar plot so it knows which column to take from the spreadsheet. So we're going to select the third overlay and tell it to take it from the cytokine 5 mean and the error bar parameter from cytokine 5 standard dev. And I'm going to change the bar color to match my gating scheme here. Cytokine 5 was that light orange. Again, that's not, mandatory, and you could use grayscale colors if you're making something for a journal, but I like to keep it colorful for webinars. All right, so again, I didn't go into as much detail in making these error bars, but that's just another way you can present the data if you're analyzing replicates, okay? And as promised, I want to show you the webinars page. So if you were to just go to denovosoftware.com, or go to denovosoftware.com and click on webinars here under the support tab, or you can go to your your startup screen and click on recorded webinars. It'll take you to the same place. We have a whole bunch of other webinars. There's one I want to point out to you, especially if you'd like to make bar plots with error bars and even asterisks showing the p-values from your t-tests for significance. We do have a webinar that will speak to you specifically about that. So if you watch this one here, that will kind of take you through that kind of analysis. Okay, so hopefully I haven't gone on too long. Thank you so much, all of you, for coming and for your interest. Just to summarize, if you don't already have FCS Express, I do hope you'll come over to denovosoftware.com or fcsexpress.com and click on Download FCS Express Demo, where you can download the fully functional demo to try it out with your own data. And if you do need any help, just click on the support button here on the startup screen. Okay, or you can just write to us at support@denovosoftware.com, jot that down. And I'm really happy to hear from any of you if you have any questions or comments about this webinar. And I'm certainly glad to sit down with you on a screen share and help you get started with your own data if you have this type of multiplex bead array data, or even a single bead that you want to kind of try it out with. I'm glad to help you start making your first standard curves and have your interpolations get going. Okay? Well, thanks again so much. It was really a pleasure having you, and we hope that we'll see you at this webinar, at the next series of webinars. Have a great afternoon. I'll be staying online in case there's any questions, so feel free to type those into the questions and answer box.